Today we're going to be calculating how to find the image location behind a mirror or in front of a mirror using two important equations. So the good news is we only have two equations to learn today, and hopefully in these two equations we will encapsulate all of the ideas that we've talked about very conceptually up until this time. So let me tell you those two equations. They both pertain to, or get us on the path of how to find the image if we already know something about the mirror and about where we put an object in front of the mirror. So we think about some mirror standing here. This is the back side of the mirror and the shiny side is right there. The first equation says that 1 over the image distance plus 1 over the object distance is equal to 1 over the focal length. Let me say a little bit about what that is in just a minute. The second equation is about the magnification, how big this image will be. The magnification is defined as the ratio of the image size to the object size. So something has a magnification bigger than 1 if it looks actually bigger than in real life. Something has a magnification less than 1 if it looks smaller than in real life. And the calculation that we're going to not prove but use over and over again is that this is related to, in a surprising way, the ratio of how far away the image is from the mirror to how far away the object is in front of the mirror. So we're imagining drawing some little axis here right through the mirror, and we're going to put our little object a distance p in front of the mirror, and back here inside the mirror might be our image. So that's I. Now I have to point out that I is not always back behind the mirror, and an important piece of information is that in these two equations everything has a sign associated with it, sign S-I-G-N. It can sometimes be positive and sometimes be negative. In fact, the magnification has a sign. If this magnification is greater than 0, it's referred to as an upright image, and if it's less than 0, this is what's called an inverted image, one that is upside down. It'll be tough for us to remember all of these details right now, so we're going to get more and more practice over the course of this lesson trying to use this, but I just want to get all these definitions up front and right away. I said that everything has a sign, even this thing called the focal length of a mirror has a sign. Sometimes it's positive and sometimes it's negative as well. So let me try to say a little bit about when something is positive and when something is negative. If we have a mirror like this, and here's our back side, and here's the axis that we're going to draw right through the mirror, and we're going to put our object right there. We define two sides of this mirror. This is called the real side. Sometimes you'll just see the abbreviation, the R side. And this is called the V side. Sometimes just called, or the virtual side. And why is this real and virtual? Where do these names come from? Well, think about this, that light is leaving this object in all different directions, some of it traveling over to the mirror and reflecting off, some of it traveling in the opposite direction. No light actually goes over to the virtual side. We see images back there, but there's never a light ray that passes back there because, in fact, the light reflects off the mirror and goes back to the real side. So real in this sense might mean we're just talking about where can light rays really go. Virtual might mean, if it helps you think about this, that light rays might appear to us to come from the virtual side, but they never really do. They only virtually appear to come to us from the V side. So anything that's over here has a sign that is less than 0. In other words, if the image was over here, this little variable I would be a number that is less than 0. Whereas if the image appeared to be on this side, it would be a number greater than 0. So everything on the real side, all these quantities like object distance and focal length and image distance, all of these are going to be quantities that are positive if they are on the real side and they are negative if they come on the virtual side. I've drawn a very flat mirror here, so this is a somewhat special case. We can talk about this for curved mirrors as well. I'm going to draw, if you remember, something called a convex mirror. This will again be the real side, and this will be the virtual side. And if we're placing an object here, this might be the distance p. That will be a positive number because it's on the object is actually on the real side. There's one other equation I forgot to tell you, and that's the focal length. The focal length, I won't derive this, is a number that's half the radius of curvature of the mirror. So this mirror has a radius of curvature to it, and the center of the curvature is back over here someplace. In other words, if I were to draw this as an imaginary kind of circular object, and I'm just taking a piece of it, the center of curvature is over here, and there's a radius. Maybe it's yay big. That's r. The focal length is half of r. I won't prove that, but simply assert it. Everything that's over on this side is positive, as I said before, since the center of curvature is over on the real side. The radius of curvature will be on the real side. It will be positive as well. So in that case, r is positive and focal length is positive. We'll see other kinds of mirrors for which the center of curvature is over on the v side, and it will be a negative number for r, and as a result, a negative number for f. And it's very important when we set up these equations up here, 1 over I plus 1 over p is 1 over f, that we use the correct sign convention, what's positive and what's negative. Because later, that will give us numbers that are meaningful for things like the magnification. The magnification comes out positive if it's an upright image. The magnification comes out negative if it's an inverted or upside down image relative to real life. And we want to get that piece of information out because remember, the kinds of information we care about for an image are its location and its magnification. And if we have that kind of information with a sign, we learn something because the sign being negative means that the image is back over here. The sign being positive for I means that the image is over here. Same way with the magnification, the sign means something. If it's positive, it's an upright image. If it's negative, it's an inverted image.